Okay, so for the second video in this week's lectures, we're going to move on from person, place, and time and how we describe our health outcomes to talking about two very specific types of studies, epidemiologic studies. And these are, in some ways, the simplest types of studies, to be very simplistic about it, I guess you could say. But they're also the types of studies, at least the cross-sectional study, that you're going to encounter the most often. And even if you don't end up working in a research context, you may be doing a cross-sectional study as part of your job. You certainly will be reading cross-sectional studies in the literature. So this is very relevant to anyone doing any type of public health work. So the idea of a cross-sectional epidemiologic study is that it's a study that examines the relationship between an exposure or an outcome in a population at the same time. Okay, so what does this sound like? This sounds like the type of study where you would end up getting a prevalence measure, right? Because you're surveying or measuring a population at one point in time. You're measuring their exposure status and their outcome status and looking at relationships between the two. And as we know, when you only measure people or assess health at one point in time, all you can end up getting from that in terms of measures of outcomes is prevalence. You don't know when the person got the health outcome. It could have been a year ago, it could have been yesterday, but on the day of your study, they have it and you can assess prevalence. So there are a few different ways you can do cross-sectional studies. Many cross-sectional studies are just population-based. So, for example, if we were to do a study of all Temple students today and we sent out an email and we said, you know, have you engaged, like the homeworks, have you engaged in these health behaviors? Do you have these health outcomes? And we looked at relationships between the two. The other way to do it is that we could specifically seek out people who have, an exposure and people who don't have an exposure. And then we want to compare the prevalence of outcomes between those two groups. We could also purposely seek out people who have certain health outcomes. So, you may want to look at children who have autism and, what is their school behavior like? So on a given day, you say, here are my kids with autism and here are my kids without autism, and then the prevalence of suspensions or the prevalence of failing grades is such and such between these two groups. Those would be two different ways to do a cross-sectional study. The key here, no matter how you collect your data, whether it's biological data or social data, whether you seek out people who have been exposed or not exposed purposely, or you just do a population-based sample, the key here is that it is at a single point in time. Any study that just measures people once and measures their current health status is a cross-sectional study. And relating back to our discussions of person, place, and time, this is how we do a lot of studies that end up looking at racial differences in the prevalence of an outcome or gender differences in the prevalence of an outcome. It's because we've measured a population at a single point in time. We've measured often a lot of demographic characteristics, and then we can look at the prevalence of our outcome across those demographic characteristics. That's a cross-sectional study, a snapshot in time. So I just have for you a few examples. I just pulled these very recently from recently published papers. So the first example of a cross-sectional study is looking at parental weight status and offspring cardiovascular disease risks, a cross-sectional study of Chinese children. So in this study, what they did is they measured people at one point in time. They measured parents and children. And so they determined parents' weight status, and then they measured among the children, and actually I'm not sure whether they took blood from these children or just measured their cardiovascular health in a less invasive way, but they were looking, the outcomes would be, if your parent is overweight, these children have this prevalence of, say, impaired fasting glucose. It's all at one point in time. It's not looking to see how children of overweight parents, their health status changes over time. It's just saying at one point in time, do overweight parents versus non-overweight parents have children with differing cardiovascular risk profiles? The next example is associations between organochlorine pesticides and cognition in U.S. elders, National Health and Nutrition Examination Survey, 1999 to 2002. So this study was conducted with data from the National Health and Nutrition Examination Survey, otherwise known as NHANES. We talked about that, I think, in week 1. It's a nationally representative sample of the health of U.S. citizens or the U.S. population. And in this study, they were just looking at associations between these specific types of pesticides and cognition in older Americans. So they probably did a survey where they talked about someone's, in their lifetime, have you been exposed to these pesticides? Perhaps what types of jobs have you done? Have you ever worked on a farm? Those type of things, and then measured their cognition. Now you may say, well, is that cross-sectional because, you're recalling back to previous exposure? And it is for the purposes of this, because we're asking about lifetime exposure to pesticides and then, cognition today. We're not looking at how cognition changes over time. And the final example I pulled out is factors associated with non-use of condoms in an online community of frequent travelers. So in this study, they just used an online message board. They put a survey on the message board and said, hey, please fill this out. And they asked about, how often to use condoms during sexual encounters, and then a wide range of other characteristics that would be associated. And again, there's no tracking people over time to see how condom use changes or how any of these predictive factors change. It says, is, let's say, race as one of the factors they measured, is race associated with a different prevalence or a differing prevalence of use of condoms among this population, and the population is the online community of frequent travelers. So again, cross-sectional study at one point in time. The strengths of this type of work are that it can be relatively inexpensive, not always, right? Because if you're collecting blood from thousands of people, it's not inexpensive. But at least you don't have to sort of maintain a study staff for a long time. Relatively inexpensive, fast, because you are doing the measurement over a very restricted period of time. And it can really, this is key, provide a first look at an exposure-disease relationship. So, you may not know what came first. We're going to talk about temporality as being a really important thing. So from these studies, you may not know what came first. But you know that there's something going on. There's some relationship between exposure to a pesticide and lower cognition. There's some relationship between a parent being obese and their child having a higher cardiovascular risk factor. Again, you would need other types of studies, which we'll talk about in the future, to be able to disentangle, well, what came first, and did the pesticides really cause the lower cognition? Or is there some other factor that could explain this? There's a lot of complexity that these studies can't always get into, but they're often the really important first step in understanding things. Okay, so in the lab assignments and as we continue to work through the class, we'll talk about cross-sectional studies a lot because as you'll start to notice as you read articles for other classes and examples, cross-sectional studies are incredibly common, in part because as a country we do a lot of cross-sectional data collection through NHANES, through the behavioral risk factor surveillance system, studies like that. And also there's just, again, relatively simple studies to undertake that get us a first view at, person, place, and time, as well as is there a relationship between the exposure and the outcome. Okay, so one specific type of cross-sectional study that I wanted to talk about is something called an ecologic study. And the idea behind an ecologic study, let's see if I zoom in here. The idea behind an ecologic study is that instead of exposure and outcome information being collected from the same individuals, so, me asking you, did you wear a bicycle helmet today and did you binge drink last night? And then looking at the association between those two things. In ecologic studies, we use information about exposure and outcome, I should say, at the group level. So groups that we're interested in are countries, differences in states, differences in census tract, differences in counties. And this gets confusing to people, and I have an example in a little bit, because, right, someone might say, well, all of our data are at the group level. Like, we're always looking at the mean body mass index for a population, or the mean level of glucose among African Americans versus Asians. But the idea here is that the data are really representative of often a geographic unit or a population, and sometimes they're not even necessarily collected from individuals, right? So some examples of group level data that we look at are per capita income, or something like air quality measures, right? That's not unique to one person. That's saying, like, within this geographic area, here's the air quality. Or policies. Policies are a great thing to measure in an ecologic study because they're not about individuals. It's not like you and your neighbor are subject to different policies. They occur on state level, national level, city level, things like that. And so we do ecologic studies when individual level measurements are not available. So say we're taking the first pass at a research question and we want to know whether meat consumption is associated with cardiovascular disease. Something we could do is look across countries and obtain measures for per capita meat consumption in a country, which may be collected by their agriculture department. And I forgot my outcome for a second. Cardiovascular mortality. So we could get other data from the government on what is the prevalence or incidence of people dying from cardiovascular disease, right? And so those two pieces of data are both grouped at a group level, at a population level, and then we can look at across countries, is there, in countries with high meat consumption, is there high cardiovascular mortality? In countries with low meat consumption, is there low cardiovascular mortality, right? We're not looking within individuals to say, did this person eat meat and did they die? They're looking at the group, in this case, countries, and do we see some relationship between meat consumption and cardiovascular mortality by different countries? And as I mentioned, it's not only used when individual level measurements aren't available, but some exposures truly are group level, such as laws, pollutions, policies. And you can't, again, if you and your neighbor are subject to the same policy, you're not going to do an individual level experiment. You're going to need to collect policy data on a city level or a state level or a country level, and that in turn brings it to an ecological study. And it used to be that ecologic studies were sort of seen as a very preliminary first step, like, oh, it's easy to obtain census data, or it's easy to obtain data on the mortality from cancer for a country. But I think this is really, the idea of an ecologic study is really growing, especially as our interest in health policy and researching the impacts of health policy is growing. And we really realize that we can sort of do these mixed studies where we look at policies on a group level and as their exposure, and then individual outcomes, or we can look at individuals nested within neighborhoods that have certain characteristics. So I think ecologic studies are very exciting, and they've sort of been brushed under the rug a bit when they shouldn't have to. So let's just, so you are dead certain on what we mean by a group level, what we're looking at in ecologic studies. So say we wanted to do a study of alcohol intake and GPA. So instead of asking each person in this class, what is your GPA, and then do you drink alcohol, and then looking at a correlation, so people who drink alcohol may have a higher or lower GPA than people who don't drink. Say we instead obtained group level data from 20 universities. So within Philly, we looked at Penn, we looked at Temple, we looked at Drexel, et cetera, et cetera. And say from the university office, we were able to obtain just one data point that was the average GPA across all students. And then say from health services department, we were able to obtain a number that was the percent of the student population reporting that they drink. And so again, we have one data point for every group, and then we can compare across universities. And so what we'd perhaps see is that there are universities that have high alcohol intake and high GPAs, and then perhaps low alcohol intake and low GPAs, and we'd start to build a correlation between those two. You may claim that, the relationship can go the other way. I don't know. I've never done this study. But that's what we mean. It's not about asking individuals, are you exposed to this and do you have this outcome? It's often obtaining sort of conglomerate, that's not the right word I'm looking for, larger level data about, what's going on in the populations. So let's go through some examples of ecologic studies. So as I was saying, studies of laws, policies, environmental factors that need to be studied on a group level. Examples of this are, does the age of getting a driver's license change the mortality due to car crashes? So the age of getting a driver's license is consistent across all people in a state. So you couldn't do a survey that said, what age did you get your driver's license? What age did you get your driver's license? Because they're all essentially going to be the same. So what we would have to do in this case is look across, say, states that have varying levels of allowing children or youth to get their driver's license, and then look at the numbers of car crashes in that state and start to build correlations between state level data. Another example is smoking bans in bars and heart attack incidents. So we may look at county laws and see, compare ones with and without smoking bans and get the heart attack incidents for the people in those districts. Another one, school-wide district food policies and obesity prevalence. So we could get from a district level, districts that have more severe policies and districts that have looser policies, and then are there differences in the prevalence of obesity across those districts? So that's what we mean by group level. It's this conglomerate. Again, I don't think that's the right word, but I'm struggling to find the right word. Someone please write me if they can think of the right word. That higher level data. Okay, so we'll go through all this. And so what's the problem with ecologic studies? I often joke that this is one of my favorite terms in epidemiology, ecologic fallacy. And this is an unfortunate outcome of some ecologic studies, and it's something to watch out for. And an ecologic fallacy, or the ecologic fallacy, is an erroneous inference, so a wrong answer, that may occur because an association observed between individuals at an aggregate level, there's the word I was looking for, aggregate, does not necessarily represent or reflect an association that exists at an individual level. So going back to our example about red meat consumption and mortality, you may find that countries with high red meat consumption have high cardiovascular mortality, countries with low meat consumption have low cardiovascular mortality, and you're able to say, there's a correlation here. It seems like high meat consumption is bad. But just because you found that at a group level does not mean that that association exists within individuals. So you're not finding that the individuals who eat a lot of meat are the same individuals who are dying from cardiovascular disease. In fact, if we look within our groups, it could be completely different people. So you just need to be really careful when interpreting data from ecologic studies to individuals, because we don't know that these two things occurred within the individual. So here is one of my, in addition to being one of my favorite phrases, here's one of my favorite studies, and this came out just a couple of years ago and caused quite a splash, actually. So here's an ecologic study where they're looking at chocolate consumption, the amount per capita per year, and the number, or the prevalence, you could say, of Nobel laureates per 10 million population. And that's the prevalence because we have a denominator of our population. And our group unit of measurement here is country, right? So this is an ecologic study where for each country they were able to obtain per capita chocolate consumption and then calculate the proportion of Nobel laureates. And what do we see here? A really nice positive association. We can draw a great line through that and saying high chocolate consumption is associated with a higher proportion of Nobel laureates. So what are the implications of that, right? Like if you weren't really thinking about things, you could say that chocolate consumption causes people to be Nobel laureates. And what are the public health implications of that? You can then say, okay, so we all need to eat a lot of chocolates and then we'll get smarter and win Nobel Prizes. So obviously, I hope you realize that that's sort of a silly thing, an ecologic fallacy. And in this case, what's probably going on is that there are other factors other sort of third factors, confounders, that are explaining chocolate consumption and Nobel laureates. So maybe these are, wealthier countries that have higher industries or something. I think, each of you could probably come up with an explanation as to why we may see an association that doesn't hold necessarily as a causal association. So here's a really nice example. Again, the data were collected on the group level, in this case country, and so each one of our data points becomes a country. It's not an individual. It's not as if they went to all the Nobel laureates and asked them, how much chocolate did you consume last week? This is all on a group level and, is intriguing but has some limitations as far as interpretation. Okay, so the strengths and limitations of ecologic studies. The strengths are that they allow us to truly study exposures that are on a population level, such as policies, laws, healthcare systems. They can be easy and expensive to generate or to produce because, again, a lot of them use publicly available data collected through the census, collected through other government agencies. And they can generate new hypotheses, new research questions. Someone could take this study and then say, gosh, I need to study at the individual level whether Nobel laureates are high chocolate consumers, or I can do an experiment where I feed my child a lot of chocolate and see if they end up a Nobel laureate. We'll talk later why that's probably not the best idea. But you get the idea that it starts to raise questions about, are there better ways to look at this? And the limitations, as we discussed in ecologic fallacy, we can observe things that may not be true on an individual level, and oftentimes actually things go in the opposite way on the individual level. I've seen that happen quite a bit. And another limitation is that alternative explanations can't be accounted for or tested, right? So, we may not have access to data that would allow us to say, well, gosh, I actually think this is about X, Y, and Z that are confounding that situation, that are masking, or creating a spurious relationship because the data may not be available. All right, let's see. So those are our two types of descriptive epidemiologic study designs, cross-sectional studies and then ecologic studies, which are a type of cross-sectional study, or can be. They may look over time, but most often they're cross-sectional. And some strengths and limitations and examples of each of those. Okay, thanks guys.